There's a story we've been told since childhood. It goes something like this. Humans crawled out of caves, learned to farm, built some temples, invented the wheel, and slowly, painfully slowly, worked their way towards civilization. Every textbook agrees. Every documentary nods along. It's clean. It's linear. It's comforting. But what if the starting point was wrong? Not dramatically wrong. Not aliens built the pyramids wrong. Just off. What if the timeline we've been using to measure human progress was based on incomplete evidence, selective interpretation, and a fundamental assumption that we were the first to get it right? Because here's the uncomfortable truth. When you actually look at the physical evidence scattered across this planet, when you measure the precision, decode the knowledge embedded in stone, and map the sudden leaps in capability, none of it behaves the way a first attempt should. Innovation is messy. It stumbles. It fails. It iterates. When we invented flight, we didn't go straight to the 747. We built gliders that crashed, engines that failed, designs that killed their pilot. The Wright brothers' first successful flight lasted 12 seconds and covered 120 feet. That's what a beginning looks like. But some of the oldest achievements we've uncovered don't look like beginnings at all. They look like applications of knowledge that was already mature, already understood, already refined through processes we can't see in the archaeological record. This isn't about rewriting history with fantasy. It's about admitting that the version we've accepted might be missing entire chapters. And if we got the beginning wrong, then everything we've built on top of it, every conclusion, every theory, every smug certainty about our place in time, might be slightly, dangerously out of focus. What follows are 7 pieces of evidence. Not myth. Not speculation. Evidence. The kind that makes archaeologists pause, engineers frown, and historians quietly rewrite their footnote. These are the anomalies we've learned to ignore because they don't fit the narrative we've agreed upon. But they're real. And they're waiting. The knowledge that arrived fully formed. Imagine trying to invent written language from scratch. Not just symbols. Actual grammar, syntax, structure. You'd need generations of trial and error. Pictograms would evolve into phonetic. Mistakes would pile up. Early versions would be clumsy, inconsistent, incomplete. Now look at Sumerian cuneiform. It appears in southern Mesopotamia around 3200 BCE, and it's not primitive. It's sophisticated, complex. It has verb tenses, abstract concepts, mathematical notation. There's no messy prototype phase. No awkward adolescence. It just shows up. Fully operational. Archaeologists have searched for the intermediary step, the crude early attempt, the learning curve, and they've found almost nothing. It's as if the Sumerians sat down one day and said, "Let's create a writing system," and then proceeded to deploy one that would remain in use for 3,000 years. That's not how invention works. The same pattern repeats with mathematics. The Sumerians didn't fumble toward a number system. They deployed a base 60 counting method so elegant that we still use it today for time and angles. 60 seconds in a minute. 60 minutes in an hour. 360 degrees in a circle. They didn't stumble into that. They applied it. And this wasn't just basic counting. They understood place value. The concept that the position of a digit determines its value, the same principle underlying our modern decimal system. They calculated square root. They had multiplication tables. They solved quadratic equations. Show these tablets to a modern mathematician, and they'll recognize the logic instantly. Because it's not primitive math. It's foundational math. The kind you build on, not the kind you struggle toward. Then there's astronomy. The Mayans calculated the length of the solar year to 365.2420 days. The actual measurement? 365.2422 days. They were off by 17 seconds. Without telescopes, without satellites, without computers. They tracked Venus with such precision that their calculations remain accurate over thousands of years. They predicted eclipses. They understood the precession of the equinoxes, a cycle that takes 26,000 years to complete. How do you observe something that takes 26,000 years unless someone before you was also watching and recording? These aren't inventions. They're implementations. When we create something new today, whether it's a smartphone or a vaccine, we leave behind a trail. Prototype, failed models, incremental improvements. The archaeological record of innovation is messy because discovery is messy. But some of the oldest knowledge we've found doesn't look messy. It looks like someone already knew the answer and just wrote it down. That's not how beginnings are supposed to work. Engineering that exceeds its own purpose. There's a difference between good enough and perfect. If you're building a storage shed, you don't need millimeter-level tolerances. If you're stacking stones to mark a burial site, you don't need laser-cut edges. You do what works. You move on. So why are some of the oldest structures on Earth built to standards that wouldn't be matched again for thousands of years? Take the granite boxes inside the Serapeum of Saqqara in Egypt. Massive, perfectly square, polished to a reflective finish. The interior corners, where two planes meet, are so precise that modern machinists struggle to explain how they were achieved with copper tools and stone hammers. We're talking about tolerances measured in microns, on objects weighing 70 tons. Engineers have attempted to recreate them using modern equipment. The results? Close but not quite. The ancients somehow achieved a level of precision that requires either technology we don't think they had, or techniques we've completely lost. But here's the strangest part. Nobody knows what they were for. They're not decorated. There's no writing. No obvious religious function. They're just there, engineered to a level of perfection that serves no clear purpose. It's like finding a Formula One engine in a society that just invented the cart. Or consider the stones at Puma Punku in Bolivia. Andesite blocks cut with such precision that they interlock without mortar. Complex geometric shape. Right angles perfect to a fraction of a degree. Surfaces so flat and smooth they appear machine-tooled. The standard explanation involves bronze chisels and patience. Lots of patience. But when modern stonemasons examine the work, they point out something unsettling. The cuts show characteristics of high-speed machining. Clean edges. No tool marks. No evidence of the pecking and grinding that should be visible if this was done by hand. It's not that hand cutting is impossible. It's that the result doesn't match the method. And then there's the Antikythera mechanism, a Greek device recovered from a shipwreck, dated to around 100 BC. It's a bronze machine with interlocking gears that tracked planetary movements, predicted eclipses, and calculated the timing of the Olympic Games. 30 interlocking gears. Differential gearing. A sophistication level that wouldn't appear again until medieval clockwork, 14 centuries later. When it was first X-rayed, scientists thought it was a modern contamination. It couldn't possibly be ancient, but it was. The mechanism required knowledge of gear ratios, astronomical periods, and mechanical engineering. It required precision metalwork. It required a mathematical understanding of planetary motion that we associate with much later period. And it wasn't unique. Inscriptions on the device reference similar machines, plural, meaning this wasn't a one-off genius invention. It was part of a tradition, a body of knowledge. So where's the rest of it? This isn't about lost civilizations building spaceship. It's about something more subtle and more unsettling, the application of knowledge that shouldn't exist yet. Not because it's impossible, but because there's no evidence of the learning curve that should have preceded it. Every technology we develop today has a history. You can trace the iPhone back to the first semiconductor. You can trace antibiotics back to early observations of mold. There's always a path. But sometimes, when we look at the ancient world, the path is missing. Just the endpoint. Already refined. Already perfected. Energy on a scale that doesn't match the era. We think of ancient humans as operating on small scales. Candles. Campfires. Maybe a forge if they were advanced. But the evidence suggests something different. In southern Jordan, archaeologists uncovered a copper production site at Khirbet en Nahas dating back over 3,000 years. The scale is staggering. Thousands of tons of slag, waste material from smelting. Industrial-level output. This wasn't a handful of artisans hammering out trinkets. This was mass production. To smelt copper at that volume, you need sustained, high-temperature fires. You need logistics, supply chains, fuel management, an understanding of thermodynamics that we usually associate with much later periods. The furnaces had to maintain temperatures above 1,000 degrees Celsius consistently for extended periods. That requires engineering, airflow control, fuel with specific energy densities. This isn't trial and error. This is applied science. And it's not isolated. In ancient Mesopotamia, there's evidence of bitumen refinement, essentially early petroleum processing, controlled chemical reactions, distillation, the kind of operations that require trial, error, and a level of expertise we don't associate with societies that were supposedly just figuring out irrigation. Bitumen was used for waterproofing, road construction, even early adhesives. But extracting and refining it requires heat management, knowledge of viscosity, understanding of chemical properties. It's not something you stumble into. Even more puzzling, traces of advanced metallurgy in South America. Bronze alloys with precise copper-to-tin ratios. Gold work involving techniques like depletion gilding, which requires knowledge of acid baths and surface chemistry. The Moche civilization of Peru created gilded objects that appear to be solid gold but are actually copper underneath. The process? They'd apply a thin layer of gold-copper alloy to the surface, then use plant-based acids to dissolve the copper atoms from the surface layer, leaving only gold visible. The result looks like solid gold but uses a fraction of the material. That's not primitive metalwork. That's chemistry. And they were doing it 1,500 years ago. None of this is impossible. But all of it requires energy control, heat management, process consistency, the kind of knowledge base that should take centuries to develop, centuries of failures, adjustments, refinement. Yet it appears early, established, confident. The question isn't whether ancient people were smart. They clearly were. The question is, how did they know what to try in the first place? Because when you're experimenting from scratch, most of what you try doesn't work. The historical record should be littered with failed attempts, abandoned techniques, dead-end technologies. But often, what we find is the finished product, already optimized, already working, as if someone skipped the rough draft entirely. The planet as a cycle, not a line. We like to think of history as a ladder. Each generation climbs a rung higher. Progress is inevitable. Civilization only moves forward. But the Earth doesn't work that way. Around 12,800 years ago, something happened. The Younger Dryas event. Temperatures plummeted. Ice returned. Megafauna vanished. Entire ecosystems collapsed. And if there were human societies that had advanced beyond hunter-gatherers, if they had built, organized, developed, those societies would have been erased. Not metaphorically, literally. The geological evidence is undeniable. Within a span of decades, perhaps even faster, global temperatures dropped. Glaciers advanced. Sea ice expanded. Species that had survived for millions of years went extinct almost overnight. Then, just as suddenly it ended, temperatures rebounded. Ice melted, and sea levels rose over 400 feet. 400 feet. Think about where human civilizations prefer to settle. River valleys, coastlines, fertile floodplains, all the places with access to water, trade routes, rich soil. All the places that would have been completely submerged when the ice melted. Any settlement near water, the most desirable, most fertile, most strategically valuable land, would have been obliterated. We know this happened. The geology is undeniable. What we don't know is what was lost. Because here's the thing, We've only excavated a fraction of the planet. And the places we haven't looked, submerged coastlines, deep jungles, desert expanses, are precisely where early civilizations would have thrived. Göbekli Tepe in Turkey wasn't supposed to exist. Discovered in the 1990s, it's a massive stone complex built over 11,000 years ago, thousands of years before agriculture, before cities, before anything we thought capable of that scale. Massive T-shaped pillars, intricate carvings, evidence of organized labor and architectural planning. It rewrote the timeline overnight. And it was just sitting there, buried, waiting. A farmer noticed some stones sticking out of a hill, and archaeologists started digging. What they found contradicted everything we thought we knew about that period in human history. How many more are there? Recent LiDAR surveys of the Amazon rainforest have revealed something astonishing. What looked like natural landscape is actually dotted with geometric earthworks, road systems, and settlement patterns. Entire cities hidden under jungle canopy. We flew over them for decades and never knew they were there. The same technology revealed massive Mayan urban centers in Guatemala. Thousands of structures. Evidence of millions of inhabitants. Previously invisible. The Earth has a habit of resetting itself. Floods, volcanoes, impact, ice ages. Each one is a delete button. And if human history has been longer than we think, then what we're seeing now might not be the first chapter. It might be the latest draft. Consider the Toba supervolcano eruption 74,000 years ago. It nearly wiped out humanity. Genetic evidence suggests the global population dropped to somewhere between 3,000 and 10,000 individuals. A bottleneck so severe that all humans alive today share remarkably similar DNA. We survived. Barely. But what if we'd been more advanced before Toba? What if there were settlements, technologies, knowledge systems that were lost in the ash and the nuclear winter that followed? There'd be almost no trace. Organic materials decay. Wood rots. Textiles disintegrate. Even metal corrodes. Within a few thousand years, almost all evidence of a civilization can vanish, especially if it's buried under volcanic ash or submerged beneath rising seas. What survives? Stone. Sometimes ceramic. And knowledge, if it's deemed important enough to remember. The rest? Gone. Objects in the wrong place. Some things don't belong where they're found. Not because they're impossible, but because their presence creates a problem for the accepted timeline. The Antikythera mechanism is the famous example, but it's not alone. In 1900, divers off the coast of Greece pulled up a lump of corroded bronze from a Roman-era shipwreck. For decades, it sat in a museum, ignored. Then someone X-rayed it. Inside were gears, dozens of them, interlocking, precise, designed to model the movements of celestial bodies. The Antikythera mechanism wasn't just advanced, it was anomalous. Nothing like it appears again in Europe for 14 centuries. So where did it come from? The usual answer is that it was a one-off, a genius invention that didn't catch on. But that explanation only works if you ignore what it implies. That someone, somewhere, had the knowledge to build it. And if they could build one, why not more? The device references similar machines in its inscriptions. It wasn't unique. It was part of a technological tradition we've otherwise lost completely. Then there's the Baghdad battery, a ceramic jar with an iron rod and copper cylinder, dating to around 200 CE. When tested, it produces a small electrical current. Was it a battery? A religious object? A medical device? No one knows. But the fact that it could generate electricity means someone understood the principles, even if we've lost the context. Modern replicas generate around a volt of electricity. Not much, but enough for electroplating, a technique that wouldn't be invented in Europe until the 1800s. Yet there's evidence of electroplated objects from the ancient world. Thin layers of gold or silver bonded to base metals with a uniformity that's difficult to achieve through other means. Coincidence? Or applied knowledge? And then there are the out-of-place artifacts that don't fit any known technological progression. The Nimrud lens, a piece of polished rock crystal from ancient Assyria, ground with optical precision. Was it decorative? Or was it actually used for magnification? When tested, it functions as a lens. Not a great one by modern standards, but functional. Which raises the question, if you can grind a lens, what else can you see? These aren't proof of ancient super technology, but they are proof that knowledge doesn't always move in straight lines. Sometimes it spikes, sometimes it vanishes, sometimes it reappears centuries later as if it had been sleeping. And that's the unsettling part, because if knowledge can be lost so completely that we forget it ever existed, if entire technological traditions can vanish without a trace, then what else have we forgotten? Greek fire, the Byzantine Empire's secret weapon, was so effective that it terrified enemies for centuries. It burned on water. It couldn't be extinguished. The formula was a state secret, guarded so closely that when the empire fell, the knowledge died with it. We still don't know exactly what it was. Roman concrete was stronger and more durable than anything produced during the Middle Ages. The Pantheon's dome, built nearly 2,000 years ago, remains the largest unreinforced concrete dome in the world. The recipe? Lost for over a millennium. We've only recently figured out what made it so special. Volcanic ash and seawater creating a chemical reaction that actually makes the concrete stronger over time. They knew. Then we forgot. Then we had to rediscover it. How many times has that happened? The human body as a biological anomaly. Evolutionarily speaking, humans are expensive. Our brains consume 20% of our energy despite being only 2% of our body weight. We're physically weak compared to other apex species. Slow. Vulnerable. Our infants are helpless for years. A massive investment of resources with no guarantee of survival. Most mammals can walk within hours of birth. Human babies can't even hold their heads up. And yet, in a geological blink, we went from chipping stones to writing symphonies. Around 300,000 years ago, Homo sapiens appeared. For most of that time, we didn't do much. Stone tools, fire, basic survival. Then, roughly 70,000 years ago, something changed. Suddenly, art, jewelry, complex language, burial rituals, abstract thought. Anthropologists call it the cognitive revolution, but that's just a name. It doesn't explain what happened. Or why. Because here's the evolutionary puzzle. Intelligence like ours doesn't offer immediate survival benefit. A stronger body would. Faster reflexes would. Better camouflage would. Thicker fur in cold climates would. But symbolic thinking? The ability to imagine things that don't exist? That's a long-term gamble. And nature doesn't usually gamble. Evolution is ruthlessly efficient. Traits that don't provide survival or reproductive advantages get selected out. Big brains are costly. They require enormous amounts of energy. They make childbirth dangerous. They extend the period of infant dependency. So why did nature invest so heavily in something that, for tens of thousands of years, didn't seem to provide much advantage over our stockier, stronger Neanderthal cousins? Unless something forced the change. Some researchers point to environmental stress, climate chaos, resource scarcity, as a driver. Pressure creates innovation. But that doesn't explain the speed of the change or its global nature. Others suggest social complexity demanded bigger brains. Humans who could navigate intricate social hierarchies, remember debts and alliances, predict behavior, they'd have had an edge. But none of that explains the sudden explosion of symbolic thought. Because abstract thinking isn't just about survival. It's about meaning, story, belief systems, things that don't directly help you find food or avoid predators. Cave paintings in Indonesia and Europe, separated by thousands of miles and created around the same time, show remarkably similar symbolic systems. Hand stencils, geometric patterns, animal depictions with spiritual significance. Why? It's as if someone flipped a switch. And once it was flipped, there was no going back. Within a few thousand years of that cognitive shift, humans had spread across the globe. We'd developed language sophisticated enough to pass down complex knowledge. We'd created art, music, mythology. We'd begun asking questions that had no survival value whatsoever. Questions like, why are we here? What happens after death? What does it all mean? No other species does this. No other species builds temples to abstract concepts, creates calendars to track time they'll never personally experience, or develops mathematics to describe things they can't see. We're biological anomalies, and the speed of our transformation is, from an evolutionary standpoint, almost unprecedented. The inheritance that survives without words. Here's a thought experiment. If every book, every hard drive, every written record disappeared tomorrow, how much of our knowledge would survive? Some. Passed down orally. Encoded in rituals. Embedded in habit. But most? Gone. Now consider this. Across the ancient world, separated by oceans and millennia, completely isolated cultures built pyramid. Not similar pyramids. Not sort of pyramids. Pyramids. Step pyramids in Mesopotamia. Smooth-faced pyramids in Egypt. Jungle pyramids in Mesoamerica. They aligned structures to the cardinal directions. They tracked solstices. They encoded mathematical constants in their architecture, pi, phi, astronomical cycles. Why? The standard explanation is convergent evolution. Similar problems, similar solutions. But that only works if the problem is obvious. And building a massive stone monument aligned to celestial events isn't an obvious solution to anything practical. It's a choice. And it's a choice repeated globally. The Great Pyramid of Giza is aligned to true north with an accuracy of 3/60th of a single degree. The Temple of Kukulkan in Mexico marks the equinoxes with a shadow serpent that descends the stairs. Angkor Wat in Cambodia encodes the precession of the equinoxes in its dimensions. These aren't coincidences. They're intentional, designed, calculated. But why the obsession with astronomy? Why did cultures across the world invest massive resources into tracking celestial events? Unless the sky was trying to tell them something, or they were trying to preserve something they'd been told. Same with flood myth. Every major culture has one. Different details, same structure, water, destruction, a remnant of humanity surviving to start over. The Sumerians have the Epic of Gilgamesh. The Hebrews have Noah. The Greeks have Deucalion. The Hindus have Manu. Native American tribes from the Pacific Northwest to the Amazon have flood stories. Australian Aboriginal cultures, isolated for 40,000 years, have them too. Coincidence? Maybe. Or maybe oral history carries more truth than we give it credit for. Because information doesn't need to be written to survive. It just needs to matter. And if something mattered enough to be repeated across generations, across continents, across the collapse of civilizations, then maybe it's not mythology. Maybe it's memory. There's a concept in archaeology called cultural drift. Over time, stories change. Details get added or lost. Metaphors become literal. Gods become heroes. Heroes become myth. But the core? The core often remains. And when the core of stories separated by oceans and thousands of years shares the same structure, catastrophic flood, survivors, rebirth, it suggests a shared origin. A common event. Something real that was so traumatic, so world-altering, that it became the foundation story for dozens of independent cultures. We know massive floods happened. We have the geological evidence. Rapid sea level rise. Mega floods when ice dams broke. Entire coastlines inundated. What if those myths aren't primitive explanations of natural phenomena? What if they're historical records? Even the number systems repeat. The Sumerians, Mayans, and Chinese all considered certain numbers sacred. 60, 360, 12, 26,000. Numbers that correspond to astronomical cycles. numbers that require long-term observation to derive. Why would isolated cultures fixate on the same values unless someone, somewhere, was teaching them? Or unless they all inherited the knowledge from an earlier source? The deeper you dig, the more the patterns repeat. Not just in structure, not just in story, but in specific technical details that shouldn't be shared across isolated populations, unless they weren't isolated, or unless they were all drawing from the same well. Not conspiracy, humility. None of this proves we're wrong about everything, but it does prove we're not done learning. The scientific method isn't about defending old conclusions, it's about updating them when new evidence appears, and the evidence keeps appearing. Göbekli Tepe, the Antikythera mechanism, precision engineering we can't replicate with the tools we think they had. Knowledge systems that appear fully formed without prototype. We're not being asked to believe in ancient aliens or Atlantis. We're being asked to admit that human history is longer, messier, and more cyclical than the simplified version we teach in schools. That some knowledge was lost. That some societies rose higher than we thought. That the timeline we've constructed is incomplete. Not because of conspiracy, but because we've only scratched the surface. Literally, 95% of the ocean floor is unmapped. Entire regions of the Amazon have never been surveyed. Deserts, ice sheets, jungles, all holding secrets we haven't even begun to excavate. Every year, new technology reveals things that were invisible before. Ground-penetrating radar, LiDAR, satellite imaging. Each innovation pulls back another layer. And every few years, something emerges that makes us rethink everything. In 2017, archaeologists using muon tomography, a technique borrowed from particle physics, discovered a massive hidden chamber inside the Great Pyramid. It had been sitting there for 4,500 years, untouched, unknown, right in the middle of the most studied structure on Earth. If we can miss something that big in a building we've been examining for centuries, what else have we missed? So maybe the question isn't, did advanced civilizations exist before us? Maybe it's, how many times has this happened? Because if the Earth is a cycle, if collapse and renewal are built into the planetary script, then we're not the first draft of humanity. We're just the current one. And that should make us a little more humble, a little more curious, a little more willing to admit that the story we've been told might only be true, up to a point. The rest is still buried, waiting to be found. And maybe that's the most important thing we can learn from the ancient world. That certainty is the enemy of discovery. That every time we think we've figured it all out, the Earth hands us another puzzle. Another artifact that doesn't fit. Another structure that shouldn't exist. Another piece of knowledge that arrived too soon. The timeline is broken. Not because someone is lying, but because the puzzle is bigger than we realize. And the pieces are still being uncovered. So what do we do with that? We keep digging. We keep asking. We stay open to the possibility that our ancestors were more capable, more knowledgeable, and more connected than we ever gave them credit for. Not because they were superhuman, but because they were human, just like us. And if they could do extraordinary things with the resources they had, maybe we've been underestimating what's possible when knowledge is valued, preserved, and passed down intentionally. Maybe the real lesson isn't about the past at all. Maybe it's about what we're choosing to build or lose right now. What do you think? Are we the beginning of the story, or just another chapter? Drop your thoughts below. And if this made you question even one thing you thought you knew, share it with someone who needs to rethink history with you. Because the more we dig, the stranger and more fascinating it gets.